As India moves towards a cleaner and more electrified transport sector, the expansion of EV charging infrastructure is becoming a critical pillar of smart utility operations. This transition is not merely about installing charging stations. It fundamentally reshapes electricity demand patterns, grid planning, and utility business models. Utility must now prepare for new load dynamics, enable smart charging to avoid peak stress, and integrate EVs as flexible energy assets. With the right digital tools, tariff mechanisms, and renewable integration, EV charging infrastructure can strengthen grid resilience while accelerating India's energy transition. I would like to present a small presentation. So, as I've briefed about the expansion of EV charging, let me very briefly introduce you about Terry. For most of the viewers here working in the energy sector, Terry is not a new name. We are the pioneers in the field of sustainability, and we were established in 1974. The key thematic areas of Terry are agriculture, climate, energy, environment, habitat, health and nutrition, and resources. Under these thematic areas, we have divisions. Particularly, I work with the electricity and renewable division, which works in the energy transition, demand side management, and energy efficiency. Emerging technologies like battery energy storage system, smart grids, green hydrogen, nuclear, electric vehicles, RE technology application, just transition, capacity building, and knowledge share. On the right hand side of the slide, you can see our key publications which are available online. For the credentials, this is some of like a glimpse of our past works. We are working very closely with the discoms like BRPL, BYPL, APDCL in Assam, GOVNL in Gujarat. And it's just not the theoretical or the academic knowledge which I bring to this discussion. It's also the practical experience of being an early EV adopter, which I have learned through driving across different terrains in India, which I'll be sharing with you today. First of all, let us know what is the importance of EV charging for the utilities. For this, a matrix would be visible to the viewers where I've divided the importance on the basis of revenue model, grid operation, and energy transition flexibility. The change is new and change is at a rapid pace. EV charging is a fast growing electricity demand segment. Local load growth requires transformers and hosting capacity planning, and EV charging can act as flexible demand for RE integration, where electric vehicles in future, where we have penetration about 30% to 40% or 50%, can act as mobile battery units. The time of use and dynamic tariffs are a crucial point and has a new revenue stream for the discoms. Integrating battery energy storage system and demand response helps in enabling V2G readiness, also using the renewable energy into the vehicles, thus making them completely green. V2G and grid balancing services enable flexibility in the market. The utilities need to shift from an electricity or the commodity seller to a service provider. EV loads accelerate smart digital distribution grids, and EV charging shift the perception needs to be shift from a grid stressor to a grid stabilizer where the flexibility can be used as an asset. For the viewers and the panelists, I have described here the three common levels of charging, wherein level 1 we have the residential slow chargers, and anything between 1.8 to 3.3 kilowatt power output charger is considered as level 1. Just to give a real life perspective of a car running with an efficiency of 100 watt hour for per kilometer, in 1 hour a car with a slow charging speed can gain a mileage of up to 18 kilometers. Similarly, for level 2, these are three phase AC or slow DC chargers ranging from 7.3 kilowatt to 22 kilowatt. And then we have the DCFC, which are the direct current fast chargers, which are the commercially available chargers. It starts from 30 kilowatt and now up to even 240 and 500 kilowatt. So the thing is, utilities need to be smarter in planning on which charger type or the level type should be allowed at which place, and should plan the tariffs accordingly. You can see on the right hand side the charging curves. When it is an AC charging, the curve is quite stable, whereas you see an erratic pattern in terms of DC fast charging. And when you add up the load, the graph is even more unstable. With emergence of multimodal peaks and coinciding peaks, because usually people charge their vehicles in the evenings when they're back from office, which also is the coinciding pattern with the evening peaks. Daytime EV charging reshapes the load profile, helps flatten peak and reduce renewable curtailment. Managed charging, and I'll repeat myself when I say that time of use tariffs are very essential to flatten these peaks. This is from a study by Terry's report titled The Decarbonization Transport in India. These are the scenarios for 2050 and 2030 respectively. So as you can see on my left hand side, it's the uncoordinated charging scenario where charging behavior remains independent of utility pricing signals. Most EV demand is concentrated during peak marginal price periods, particularly in the evening hours. Whereas on the right hand side, the load curve is quite stable. It is because of the coordinated charging scenarios, using price signals to optimize charging schedules, shifting a significant share of charging into the morning hours when electricity prices are low. This optimized charging at low tariff period help reduce peak demand stress on the grid, improve load balancing, and supports more cost-effective charging for the consumers and the fleet operators. In this fast-paced emerging technology, there are a few challenges, but there is also a ray of hope and new solutions to it. The EV load has increased the peak demand, and because of which there is a high congestion in the feeders, also leading to high price of energy and system services. The solutions are manifold. They can be conventional, like invest in reserves and peaking power plant, but that might be on the cost of environmental degradation through coal and emissions. Alternatively, what we can do is give the price signals and incentivize the load shifting and grid utilization to the time of use uh, charging. Flexibility measures can be used, and demand side measurements are essential for shifting the peak. The smart charging and digital solution EV Hub act as an ecosystem where we need to check the two-way patterns, where the EV electric vehicles are charging in multiple numbers, such as fleet operators or the bus. There is a huge potential for V2G operation, that is vehicle to grid. Smart metering is required. From probabilistic forecasting, we should get into preemptive predictive forecasting through machine learning and AI load forecasting. Dynamic pricing is essential. This will lead to a 30% reduction in the peak load and a 2x grid efficiency gain. This is again from Terry's study where we have compared. So the blue line you see is the power demand from the Mundela charging station, which is the DTC charging hub for electric buses, and the red line is the BRPL. So, as I was suggesting, just in the morning hours from 6 o'clock when the wind starts, and then at 8 when the solar also gains power, we can store the energy. And then this stored energy can be used for charging during the midday and the evening peak hours, thus flattening the curve. Policy and planning is a must. India is a leader in adoption of renewable energy. We look today at a 450 plus gigawatt of installed capacity in total, out of which 180 plus gigawatt is of renewables. The challenge remains is managing the variability, the scale, and reliability in real time. The shift is definitely underway. Instead of just infrastructure expansion, a systematic and intelligent approach is required. Reactive fault management is a redundant practice. We should be preemptive and predictive, and the planning should be in that way. Isolated assets are of no use. Integrated and digital ecosystem should be adopted. This will lead to an energy transition which is inseparable from digital transformation. Even the union budget this year gives a very heavy push on energy and digital revamp of the whole ecosystem. The RDSS scheme has the smart meter rolling out with infrastructure upgrades and operational efficiency reforms. The India Energy Stack, which is the pioneering digital public infrastructure launched by Ministry of Power to create a unified, secure, and interoperable digital backbone for the power sector, is a data-driven utility governance. Continued funding for the grid modernization is there. Support for battery energy system storage can also be seen in the budget. Expansion of EV charging infrastructure is inevitable, and digital public infrastructure push is what we require now. As the Union Minister, Honorable Union Minister of Renewable Energy said, and I quote, that energy transition must be matched by the grid transition. What does this mean for the policy and planning? This means that battery storage must be integrated to the mainstreaming. And urban planning and load forecasting and charging infrastructure must be aligned with state power plans. Clear rules for data sharing, cybersecurity, and consumer participation are crucial. I'll conclude by saying that the future grid will not only power the vehicles, it will be powered by them. Thank you.